Hi, I'm an old guy and I do maths. What we're tasked with today is finding a general solution to this equation here, which is root 3 cos 2x times tan 2x equals cos 2x. Now, I thought long and hard about how I get this into a form in which it can be worked with. And my initial temptation was to do something to the tangent here, maybe rewrite it as sine over cos, but that really didn't yield terribly much. So I've gone about this in another way, which is to essentially create a quadratic out of this and solve both parts of that quadratic for 0. So the first question is, how do we get to a point where we are looking at something equaling 0? Well, that's fairly simple. What we're going to do is we're going to take cos 2x from both sides, and the result looks like this. Root 3 cos 2x tan 2x minus cos 2x equals 0. Now, we can achieve a quadratic form as follows. Now, this is going to take a slight redistribution of this root 3. I'm going to move this to here. It makes no odds because we have root 3 times cos 2x times tan 2x. We can just as easily have cos 2x times root 3 times tan 2x, and we get the same result. So let's do that. Cos 2x root 3 tan 2x minus cos 2x. I'm going through all the steps here so that you can see this clearly. Now, we have cos 2x times root 3 tan 2x minus cos 2x. How can we factorize this? Well, this is how. Cos 2x times root 3 tan 2x. Now that's going to give us that times that, or if you want to look at it this way, that times that. No question there. Minus 1. And that's going to give us our cos 2x, our negative cos 2x over here. Now, the question is, where does the cosine of 2x equal 0? That's one of the factors that we're going to make equal 0. This is the other factor that we will make equal 0, and we'll come to that in a moment. Well, where is the cosine of x? Note I say the cosine of x equal to 0. A very quick little drawing here, a very rough sketch of y equals cos x. Please note, not 2x. Here and here we have the cosine of x equaling 0. Now, this point is pi on 2. If we take into account the fact that this is 2x, what our graph looks like, instead of having 2 pi here, we have pi, which means that every measurement along here has been halved, and so this becomes pi on 4, and this is 3 pi on 4. So our solutions to this between 0 and 2 pi would be pi on 4 and 3 pi on 4. So if we write that in general terms, x would be equal to pi on 4 plus pi n. Now normally this would be pi 2n, I think, just off the top of my head while I'm doing this, but please note that our period is 1 pi, not 2 pi. So that's the first part of it, and x can also be 3 pi on 4 plus pi n. And this also works in the negative direction. It would be minus pi n and minus pi n here. So that's the first part of this. Now I'll just talk you through the second part of the solution. We're trying to solve root 3 tan 2x minus 1 equals 0. We're trying to find a solution for this, a general solution. We can rewrite this as tan 2x equals 1 on root 3, simply by a little bit of algebraic manipulation. Now, where the tangent of x, and I emphasize that, x, not 2x, is equal to 1 on root 3 is here at pi on 6. Now, for the reasons that we halved the other solution, we also have to have this solution for x because we are dealing with 2x. So 2 times pi on 12 will give us pi on 6. There's our answer. Now, you might think that that is the end of it, but there's a problem. We were given this as a whole equation, and if we were to put what had we got? We've got pi on 4 and 3 pi on 4. If we were to put these values into an equation y equals tan 2x, because we would fall on an asymptote with each of these solutions are actually out as far as a solution to this is concerned. So we actually only have one solution for our equation, and it's the one that we arrive at with the tangent. It is this one. X is equal to pi on 12 plus pi n on 2 as a general solution. And of course this will work in the negative direction as well. So I hope you found that useful and interesting. If you did, please like and subscribe, and I'll see you next time. Bye.